Unit 2A, Lesson 4. In this unit, we're going to talk about two standards. The first one, understand that by similarity, side ratios in right triangles are properties of the angles in the triangle, leading to definitions of trigonomic ratios for acute angles. The second standard is, explain and use the relationship between the sine and cosine of complementary angles. First, we are going to discuss how to find the 6 trig ratios for a right triangle. We're going to refer to the acronym SOHCAHTOA, or as some past students have called this, Sacagawea, whichever you prefer. SOHCAHTOA helps us remember which side lengths we're going to use for sine, cosine, and tangent. Alright, so first we're going to focus on these three, and then once we understand these three, we're going to talk about cosecant, secant, and cotangent. So if we look at this right triangle, we have our right angle. We're going to be focusing on angle theta in this case. If this is angle theta, the hypotenuse is always the side opposite of the right angle. The adjacent side is one of the legs of the right triangle that is adjacent right next to the angle we're referring to. And then we have the opposite side, which is the other leg that's opposite of the angle we're referring to. Okay? So, first, let's focus on SOH. The S is referring to sine. O stands for opposite. And H stands for hypotenuse. So if we're trying to find the sine of theta, that is going to be equal to the length of the opposite side divided by the length of the hypotenuse. CAH stands for cosine, and that is referring to cosine of theta is equal to the adjacent side divided by the hypotenuse. Then the last part, TOA, tangent of theta is equal to the opposite side divided by the adjacent side. Okay, so using the side lengths of a right triangle to find these special trig ratios. Once we have that, now we can focus on cosecant, secant, and cotangent. The sine of theta is related to the cosecant of theta because they are reciprocals. So the cosecant of theta is going to be equal to the hypotenuse divided by the opposite side. All we do is take our sine of theta, flip the numerator and denominator. The secant of theta is the reciprocal of cosine, so that is going to be equal to the hypotenuse divided by the adjacent side. Finally, cotangent is related to tangent. Those are reciprocals as well. So cotangent of theta is going to be equal to the adjacent side divided by the opposite side. So we are going to be working with all 6 of these trig ratios. These only work if we are talking about right triangles. In example 1, we want to find all 6 trig values for the given right triangle. Right? So we're provided with some information. We know what the hypotenuse is, and we know one of the legs of the triangle. Okay? So first, we have to be able to find this other leg using the Pythagorean theorem. A squared plus b squared is equal to c squared. So right now, I'm just going to say that this is length A. That's what we need to find. So a squared plus b squared would be 24 is equal to 26 squared. So using some algebra to simplify, a squared plus 576 is equal to 676. If I subtract 576 to the other side, we would have a squared is equal to 100. Then take the square root of each side. A is equal to 10. Technically, when we take the square root, we would have 2 answers. We would have plus or minus, but since we're talking about a distance, a length, we can't have a negative distance, so we only focus on the positive. So the length of this side is 10. Now we can go through and find all of the trig ratios First, we're only going to focus on angle U right now, okay? Because technically, we can find the 6 trig values for angle U and angle T, the two acute angles. We're just going to focus on angle U right now. So the sine of, we have to say what angle we're working with. The sine of U is equal to SOHCAHTOA. Sine is opposite over hypotenuse. So we have the opposite side, which is 10, over the hypotenuse, 26. 10 over 26. Cosine of U is equal to the adjacent over the hypotenuse, which would be 24 over 26. And tangent of U is opposite over adjacent, which would be 10 over 24. Now once we have these three, we can go through and find the other 3 trig ratios. Remember, this is a little confusing, but the trig ratio that corresponds to sine is cosecant. So the cosecant of U is equal to the reciprocal of sine, which would be 26 over 10. Secant of U is the reciprocal of cosine, which would be 26 over 24. And cotangent of U is a reciprocal of tangent, which is 24 over 10. So first we had to use the Pythagorean theorem to find the missing length in this right triangle. And then we could go through, first find sine, cosine, and tangent using SOHCAHTOA, that acronym, and then using the ideas of the reciprocal for cosecant, secant, and cotangent. Some of you might be wondering, looking at all these fractions, they can all be simplified because they all have a factor of 2. Technically, we don't need to simplify these. We're just looking at this ratio. If you had a multiple choice standardized test, one of your answers might be for the sine of U 5 over 13. You would just have to recognize that this ratio could be simplified down further. This next example, very similar. We want to find all 6 trig values for this right triangle. Again, we have to use the Pythagorean theorem to find the missing length. The missing length in this case is the hypotenuse. So using the Pythagorean theorem, we have 2 radical 3 squared plus 8 squared equal to c squared. Make sure to put the 2 radical 3 in parentheses, because when we square this, we have to square the 2 as well as the radical 3. So 2 squared is 4 times radical 3 squared is 3 plus 8 squared is 64 equal to c squared. 4 times 3 is 12 plus 64 is equal to c squared. So 76 is equal to c squared. And now we could take the square root of each side. C is equal to the square root of 76. This is where we want to simplify this, break it down if we can. 76 is the same as radical 4 times radical 19. So we can break the square root of 76 down into the square root of 4 times the square root of 19, because 4 times 19 is 76. The reason we do that, the square root of 4 simplifies down nicely. It's a perfect square. So this is 2 radical 19 is the length of our hypotenuse. So now we have all 3 lengths of this right triangle. We can go through, find the sine, cosine, tangent, and then the cosecant, secant, and cotangent. In this problem, let's work with angle V, switch up what we did the last time. So if we're looking for the sine of V, that's equal to the opposite over the hypotenuse. The opposite side to V is 8. So this is 8 over 2 radical 19. The cosine of V is going to be equal to the adjacent over the hypotenuse. So 2 radical 3 over 2 radical 19. And now the tangent of V is equal to the opposite over the adjacent, 8 over 2 radical 3. Again, we could simplify all of these fractions down. They have factors of 2 in common. We don't need to work on that right now. You should know how to simplify fractions down. Now we can go through and find all the reciprocals. We have the cosecant of V, which is going to be the reciprocal. So 2 radical 19 over 8. The secant of V, which is equal to 2 radical 19 over 2 radical 3. And then the cotangent of V is equal to 2 radical 3 over 8. So these are the 6 trig ratios for angle V. Like I said in the last example, we could also find the 6 trig ratios for angle T as well. To end this lesson, we're going to discuss complementary angles and use them to find trig values. Alright, so let's focus on this 3, 4, 5 right triangle, a very common right triangle. And I told you to find the sine of angle A. If you recall, sine of A, sine is opposite over hypotenuse, so this would be equal to 4 over 5. And then I told you to find the cosine of the other acute angle, which would be the cosine of C. Cosine, if you recall, is equal to adjacent over hypotenuse, so that would be 4 over 5 as well. Those two values, as you can see, are equal to each other, and this will always be true. The sine of one acute angle is always going to be equal to the cosine of the other acute angle in a right triangle. So using that information, we can take this a step further. If I told you that the sine of 55 degrees is equal to 3/7. From that information, we would be able to determine that the cosine of some angle is also equal to 3/7. Okay, so the cosine of what angle value now? Well, if they're complementary, complementary means they add up, have a sum of 90 degrees. So if you take 90 minus 55, you get 35 degrees. So if we had a triangle, I don't know if these numbers are necessarily true, I just made them up. But sine and cosine, when we're dealing with right triangles, have this complementary property. So the sine of one angle, one acute angle, is equal to the cosine of the other acute angle. So in this lesson, you learned the 6 trig ratios for a right triangle, the acronym SOHCAHTOA, helping you remember sine, cosine, and tangent, and then using the reciprocal properties to find cosecant, secant, and cotangent. And then also referring to the complementary properties for the trig values of right triangles. The sine of one angle is going to be equal to the cosine of the other acute angle in a right triangle.